area and volumes of similar figures. We did something really, really similar to this at the end of chapter 10, where we talked about similar perimeters and areas, and so this is going to be very, very similar to that. So first of all, let's talk about similar figures. They have the same shape, and all their corresponding dimensions are proportional. So I have two examples here. So I want to show you what it would look like if something is considered a set of similar figures and something that's not. So it says their corresponding dimensions are proportional. What that means is if I were to take corresponding side lengths and set up all of the ratios of the corresponding side lengths, they should come down to be the same fraction. So for example, if I look at these two figures here, the left-hand side here and here, if I write that as a ratio, like 3/6, if these two figures are similar, that is going to be equal to if I did it with all of the other corresponding sides. So like this bottom front edge would be also 3/6, obviously those are the same. And then this one going back here would be 2/4. Notice that all three of these would reduce down to 1/2. Since all three of them are proportional, we'd say yes, those are similar figures. Now if I jump over to this one here, we could do the same thing. So if I look at these left-hand sides, we have 2/3. If they are similar, I should be able to take that bottom edge, 3/6, and should be equal to, if I do the other one, it'd be 2/3. Now here's the thing, the first and the third are both 2/3, but this second one here, that would reduce down to 1/2, and even though it's just one of them, it doesn't matter. It would have to be all of their corresponding dimensions have to be proportional. So these would not be considered similar figures. Okay, so this is going to be the important stuff here. So our Theorem 1112 talks about areas and volumes of similar solids. So a scale factor is going to be what we found up here. So the scale factor for this first one, since they were similar figures, just basically says how much larger or how much smaller is one of the objects to the other. For this first one, since their ratios simplified 1:2, the scale factor of the side lengths is 1:2. That second figure is always going to be twice as big as the other one. So one of the big things we're going to want to be able to do today is find that scale factor. So if the scale factor is A to B, whatever it may be, 1:2, 4:5, whatever it is, the ratio of their corresponding areas is going to be A squared to B squared. And we kind of already did that in the last chapter when we talked about areas of similar polygons. Their areas were the A to B but squared. And the ratio of their corresponding volumes is going to be A cubed to B cubed. So here's what we're going to do with this. This example down here says the square prisms are similar. What is the scale factor of the smaller prism to the larger prism? So I'm given that I have the volume. So I have the volume of one is 729. The volume of the other is 1,331. So what I want to do is I want to write their volumes as a ratio, and I want to write it as a ratio from the smaller to the larger. So we're going to put 729 over 1,331. Now, these are the volumes. What this theorem up here told me is that their volumes, okay, their corresponding volumes are A cubed to B cubed. So where I got that 729 and 1,331, I took something cubed over something else cubed. That's my scale factor that I'm looking for. So to figure out what this is, sometimes these numbers will be easy, but sometimes they're not going to be perfect. So to figure out what would I need to cube to give me 729, we did this a little bit yesterday, we need to take the cubed root. What multiplied by itself 3 times gives me 729. So when you take the cubed root of 729, you get 9. And when you take the cubed root of 1,331, you get 11. So the ratio, the scale factor from the smaller to the larger is going to be 9/11. Now we're going to kind of take this a step further where we talked about the scale factor to help us find surface area and volumes of similar figures. So this one says we have the volume of two similar containers are 115 inches cubed and 67 inches cubed. The surface area of the smaller is 108 inches squared. What is the surface area of the larger container? So the first thing that we want to be able to do is we want to be able to find that scale factor, that A to B. So I need to start with the ratio that I know. Now they tell me that the volumes are 115 to 67. Okay, so I know both of the volumes. So what we're going to do first is we're going to write that as a ratio. So 115 over 67. Now this is volume. So this was something cubed over something else cubed. I need to figure out what those numbers are. So I need to figure out what would I cube to get 115. So we're going to take the cubed root of 115. I need to figure out what cubed would give me 67. So I need to take the cubed root of 67. And when you do this, you are going to get decimals. So we'd end up with about 4.86 over about 4.06. Now, here's the thing. That is the ratio of their side lengths. That is their scale factor. What I'm looking for is I am looking for surface area. The ratio of their surface areas, looking back at that theorem, is going to be this, both squared. So when I'm talking about areas, I want to take that scale factor and square them. So when you take 4.86 squared, you should get about 23.62. And when you take 4.06 squared, you get about 16.48. Okay, so what this tells me is that for these two similar figures, the ratio of their surface areas would be equivalent to this ratio here. So we did this back in chapter 10, but what I need to do is I need to set up a proportion. So 1/2 of my proportion is going to be that ratio there, 23.62 over 16.48. Now notice that 23.62 is going to be my larger figure. That 16.48 is going to be my smaller figure because one's larger and one's smaller. So what the other information I'm given is it says the surface area of the smaller is 108. So on the other side of my proportion, I know the smaller surface area. So I'm going to plug in that 108 right there. I am looking for the surface area of the larger. So I can set up a proportion. And as a reminder, to solve proportions, we use cross products. So when I take 108 times 23.62, I get about 2,550.96. That is equal to, when I go up and across the other way, I get 16.48x. And then to solve for x, divide by 16.48, and we should get about 155 inches squared. So a lot of what we're doing today is going to be setting up these ratios and then solving these proportions. So let's go ahead and get this glued into page 63. This is section 11.3, and it is surface area and volumes of similar figures. Okay, and then once you get that glued in, let's jump over and we'll knock out a few examples here. So one of the first things you're going to be doing in your homework is you're going to be just deciding if figures are similar or not. So that's going to be like the examples we did on the left-hand side. Remember, if they are similar figures, all of their corresponding side lengths should be proportional. So you have to check all of them and make sure that they are equal. Okay, so then what you're going to be doing is you're going to be finding the scale factors. So for number 1, we're going to have these two rectangular prisms here. One larger than, these are terrible, I'm sorry. One larger than the other. Let's say this, the first one's the smaller one, and it has a surface area of 144 meters squared. The other one has a surface area of 324 meters squared. Okay, what we are trying to do here is we are trying to find the scale factor. So to find the scale factor, we need to first set up a ratio of the information that I'm given. Now we want to find the scale factor from the smaller to the larger. So when we're setting up our ratio, let's take the smaller number and write it over the larger number. Now, since we are talking about surface area, where these numbers came from is I took the scale factor and I squared it to get these numbers. So to get back to the scale factor, I need to square root these. So the square root of 144 is 12. The square root of 324 is 18. Now, like always, I hope that we are expecting to reduce this, because in math, we always want to write our answer in simplest form. And so if I were to reduce this, we would get 2/3. So the scale factor there would be 2 to 3. Okay, so you're going to have a few of those, but let's go ahead and let's move on to finding that scale factor and then using it to find some other information as well. So this one says we are given the surface area of two similar figures. We are going to find the volume of the smaller figure when we've been given the volume of the larger. So let's say we have figures. One has a surface area of 36 meters squared. The other has a surface area of 225 meters squared. The larger, so it tells me that this is the larger volume, it has a volume of 750 meters cubed. Okay, so the first thing that we are going to want to do here is we want to find that scale factor. So I'm given the surface area of both. So let's go ahead and let's write a ratio of their surface areas. So if I do 36 over 225. Now what I'm looking for is the scale factor, that A to B. Once I found that A to B, where I got this 36 over 225 is I squared A and I squared B. So I need to figure out what squared gives me 36, what squared gives me 225. So we're taking the square root of each of those. We get 6 over 15. Probably would always be best to write this in simplest form, so we could call it 2 over 5. All right, so now, what I'm trying to find, I am trying to find the volume. So this is the ratio of their side lengths. Remember, if I want to find the ratio of their volumes, I need to take that scale factor and I need to cube them. That's what that theorem tells me. So if the ratio of their side lengths is 2 over 5, the ratio of their volumes is going to be 8 over 125. And then once I have that ratio, 8 over 125, I can set up a proportion. Now my proportion, how I have it written, has larger over smaller. So on the right-hand side, it also needs to show larger over smaller. So this volume that I have here is the volume of the larger. So I'm going to put that 750 down there on the bottom, which means my x, my variable, is going to go on the top. And then to solve our proportion, I could take 750 times 8, which gives me 6,000. 125 times x just gives me 125x. Divide by 125, and we should get 48 meters cubed for that other volume. Okay, and then lastly, we'll just kind of go the opposite way. So this time we'll be given volume, and we want to find the surface area of the larger when we are given the smaller. So let's say we have the volume of one is 40 inches cubed. The volume of the other is 135 inches cubed. And the surface area, and it tells me that this is the surface area of the smaller, is going to be 48 inches squared. All right, so the first thing we want to find is we want to find that scale factor. So we're going to write the ratio of their volumes. So I'm going to do 40 over 135. Once again, remember, what I'm looking for is the a to b. What I have is I have the a cubed to b cubed. So what I'm going to do is I'm going to take the cubed root of each one of those to tell me what cubed would give me 40 and 135. These are definitely going to give you some decimals, gives you about 3.42 over about 5.13. Now remember, that is the ratio of their side lengths. The next thing I'm going to talk about is their surface area. So their side lengths is a to b, their volume is a cubed over b cubed, their surface area is a squared over b squared. So what I want to do is I want to take that 3.42 over 5.13 and we're going to square them. So these give me, I'm going to keep a couple extra decimal places here, gives me about 11.696 and 26.317. Now this is the ratio of their areas. So I can write this and set up my proportions. So 11.696 over 26.317. My ratio has smaller to larger. So what I've been given is I've been given the surface area of the smaller this time. So that number that I was given, that 48, it needs to go in my numerator because I have it written smaller to larger. And then if I do my cross products, we'd have 11.696x. When I multiply up and across the other way, we should get about 1,263.216 and divide so we can solve. And we should end up with about 108 inches squared for the larger figure.